When terminating a stranded wire on a Siemens QP-type circuit breaker installed in a load center, and the QP breaker has a screw-type terminal, and some of the wire strands push out from under the screw, resulting in an inferior connection, consider these options. Firstly, using a wire ferrule is a preferred method for terminating stranded wire on this type of circuit breaker. Select a ferrule with an appropriate size and insulation, such as copper or tinned copper with a closed barrel. Strip the wire insulation to the proper length, consulting the manufacturer's instructions for the correct measurement. Slide the ferrule onto the stranded wire and crimp it using an appropriate tool designed for ferrules. Insert the ferrule into the screw terminal and tighten the screw securely to the recommended torque. Secondly, another option is to use a lug-type wire connector. Select a lug with an appropriate size and insulation, for example, copper or tinned copper with a ring-type configuration. Slide the lug onto the stranded wire and crimp it using an appropriate tool designed for lugs. Attach the lug to the screw terminal using a bolt or nut and tighten securely to the specified torque. Additional tips to keep in mind include ensuring that all strands are properly secured under the screw or terminal, whether using a ferrule or a lug. Avoid over-tightening the screw or terminal, as this can damage the wires or the breaker itself. If necessary, a small dab of electrical grease can be used to improve conductivity and prevent oxidation at the connection point. Always double-check the tightness of the connection after completing the installation to ensure a secure and reliable connection. There are several advantages to using a ferrule or lug when terminating stranded wire. Firstly, it provides a more secure connection that prevents the stranded wires from pushing out from under the screw terminal. Secondly, it improves current flow and reduces electrical resistance at the connection, leading to a more efficient and safer electrical system. Thirdly, it facilitates easier inspection and maintenance of the connection, as the ferrule or lug provides a clear and defined termination point. It is important to note that tinning the wire strands is not recommended for this application. Tinning can weaken the wire and create a brittle connection that is more prone to failure over time. The use of a ferrule or lug provides a much more reliable and durable termination method for stranded wire on a QP circuit breaker with a screw terminal. Selecting the appropriate size ferrule or lug is crucial for a proper termination. The size should correspond to the wire gauge being used, in this case, number 12 American wire gauge. Consult the manufacturer's specifications for the ferrule or lug to determine the correct size. Using a ferrule or lug that is too small can result in an inadequate connection, while using one that is too large can prevent the screw terminal from tightening properly. The crimping tool used to secure the ferrule or lug to the wire must also be appropriate for the size and type of ferrule or lug being used. Using the wrong crimping tool can result in a faulty crimp, which can compromise the integrity of the connection. Ensure that the crimping tool is properly calibrated and that the correct die is used for the specific ferrule or lug being installed. When tightening the screw terminal, it is important to use the correct torque specified by the manufacturer. Over-tightening the screw can damage the wires or the breaker, while under-tightening it can result in a loose connection. A torque wrench should be used to ensure that the screw is tightened to the correct specification. When using a lug-type wire connector, ensure that the lug is properly oriented on the screw terminal. A lug should be positioned so that the screw applies direct pressure to the lug, rather than to the wire strands. This will help to ensure a secure and reliable connection. When working with electrical wiring, it is always important to follow proper safety precautions. Turn off the power to the circuit breaker before making any connections. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electrical wiring, consult a qualified electrician. In summary, when terminating a number 12 American wire gauge stranded wire on a Siemens QP-type circuit breaker with a screw terminal, using a wire ferrule or a lug-type wire connector is the preferred method. Select the appropriate size ferrule or lug. Use the correct crimping tool and tighten the screw terminal to the specified torque. Avoid tinning the wire strands and always follow proper safety precautions when working with electrical wiring. By following these guidelines, a secure and reliable connection can be ensured. Remember to always consult the manufacturer's instructions for the circuit breaker, ferrules, lugs, and crimping tools to ensure proper installation and compliance with applicable electrical codes. Correctly installed and properly sized components are key to a safe and lasting electrical connection. Regularly inspect electrical connections, especially those subjected to vibration or temperature changes. Look for signs of corrosion, loosening, or damage. If any issues are found, promptly address them to prevent potential problems. Always to energize the circuit before performing any maintenance or repairs on electrical connections. Using a voltage tester to verify the absence of voltage is an essential safety step. Proper wire stripping is critical for making good electrical connections. Use a wire stripper tool that is appropriately sized for the wire gauge to avoid nicking or damaging the conductor. The correct stripping length ensures adequate contact area within the terminal without exposing excessive bare wire. When multiple conductors are terminated at the same terminal, ensure that the terminal is designed and rated for such use. Avoid overloading terminals beyond a specified capacity, as this can lead to overheating and failure. Consider using distribution blocks or other suitable solutions for managing multiple connections safely and effectively. Always refer to the National Electrical Code, or NEC, and local electrical codes for specific requirements and regulations related to wire terminations and electrical installations. These codes provide essential guidelines for ensuring safety and compliance. Document all electrical work performed, including details about wire sizes, termination methods, and torque specifications. Accurate documentation facilitates future inspections, maintenance, and troubleshooting. Labeling wires and connections can also improve clarity and reduce the risk of errors. Electrical connections can be affected by environmental factors such as moisture, temperature, and corrosive substances. Take appropriate measures to protect connections from these elements, such as using weatherproof enclosures, corrosion inhibitors, or insulated connectors. Periodic inspections can help identify and address potential environmental-related issues before they cause problems. When working with aluminum conductors, use connectors and terminations that are specifically designed and rated for aluminum. Aluminum conductors require special consideration due to their unique properties such as higher thermal expansion and oxidation potential. Applying an antioxidant compound can help prevent corrosion and ensure a reliable connection. Properly grounding electrical systems is essential for safety and protection against electrical shock. Ensure that all grounding connections are secure and meet applicable code requirements. Regularly inspect grounding connections for corrosion or damage, and promptly address any issues. When making electrical connections, avoid creating sharp bends or kinks in the wires, as this can weaken the conductor and increase the risk of breakage. Use smooth, gradual bends to maintain the integrity of the wire. Secure wires properly to prevent strain on the connections. Always ensure that the circuit breaker is properly sized for the circuit it protects. Using an undersized breaker can result in use and stripping, while using an oversized breaker can create a fire hazard. Calculate the circuit load accurately and select a breaker that is appropriately rated. Circuit breakers should be tested periodically to ensure they are functioning correctly. Testing can be performed using a circuit breaker tester, which simulates fault conditions and verifies that the breaker trips as expected. Replace any breakers that fail to operate properly. When replacing a circuit breaker, use a breaker that is the same type and rating as the original. Avoid using substitute breakers that may not be compatible with the electrical system. Consult the manufacturer's specifications to ensure that the replacement breaker meets the required standards. Over time, circuit breakers can degrade due to age, wear, and exposure to heat and humidity. It is recommended to replace circuit breakers periodically, even if they appear to be functioning correctly. A general guideline is to replace breakers every 25 to 30 years, or sooner if there are signs of degradation. Before working on any electrical equipment, ensure that you have a thorough understanding of electrical safety principles and procedures. Electrical work can be dangerous if not performed correctly. If you are unsure about any aspect of the work, consult a qualified electrician. Always double-check your work to ensure that all connections are secure and that all safety precautions have been followed. After completing the work, test the circuit to verify that it is functioning properly. Look for any signs of problems, such as flickering lights, overheating, or unusual noises. If any issues are detected, address them promptly. The National Electrical Code, or NEC, is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Staying up to date with the NEC is essential for ensuring compliance and safety. Consult the latest edition of the NEC for specific requirements and regulations related to electrical installations. Electrical codes and standards are constantly evolving to improve safety and efficiency. Participate in continuing education and training programs to stay informed about the latest developments in the electrical industry. Learning about new technologies and best practices can help you improve your skills and knowledge. When working on electrical systems, always prioritize safety. Electrical hazards can cause serious injuries or even death. Take the time to plan your work carefully and follow all safety precautions. If you are not comfortable working on electrical equipment, consult a qualified electrician. Remember that electrical work is not a do-it-yourself project. It requires specialized knowledge, skills, and tools. Attempting to perform electrical work without proper training and experience can be dangerous. Consult a qualified electrician for all electrical work. A properly installed and maintained electrical system is essential for the safety and reliability of your home or business. Take the time to ensure that your electrical system is functioning correctly and that all safety precautions are being followed. If you have any concerns about your electrical system, consult a qualified electrician. Always use electrical components and equipment that are listed or certified by a recognized testing laboratory, such as Underwriters Laboratories, or Electrical Testing Laboratories, or ETL. Listed or certified products have been tested to meet safety standards and are more likely to perform reliably. Avoid using counterfeit or substandard electrical products, as these can pose a serious safety hazard. Always purchase electrical components and equipment from reputable suppliers. Be wary of products that are sold at significantly lower prices than similar products from established brands. Counterfeit electrical products may not meet safety standards and can fail prematurely or cause fires. When installing electrical boxes, ensure that they are properly sized for the number and size of conductors being installed. Overcrowded electrical boxes can create a fire hazard. Use electrical boxes that are made of non-combustible materials, such as metal or fiberglass. Ensure that all electrical boxes are securely mounted to a structural member. Avoid using electrical boxes that are damaged or corroded. Replace any damaged or corroded electrical boxes promptly. When running electrical wiring through walls or ceilings, protect the wiring from physical damage. Use conduit or other protective measures to prevent the wiring from being punctured or cut. Avoid running electrical wiring through areas where it may be exposed to moisture or chemicals. Use appropriate sealing methods to protect the wiring from moisture or chemicals. When installing electrical outlets or switches, use devices that are tamper-resistant. Tamper-resistant outlets and switches have a built-in safety mechanism that prevents children from inserting objects into the slots. Install ground fault circuit interrupter, or GFCI, outlets in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor locations. GFCI outlets can protect against electrical shock by interrupting the circuit when a ground fault is detected. Test GFCI outlets regularly to ensure they are functioning correctly. If a GFCI outlet fails to trip when tested, replace it immediately. When using extension cords, use cords that are the correct gauge for the load being served. Undersized extension cords can overheat and create a fire hazard. Avoid using extension cords as a permanent wiring solution. If you need a permanent outlet, install one. Do not overload extension cords. Overloading extension cords can cause them to overheat and create a fire hazard. Plug only one appliance into each extension cord. Inspect extension cords regularly for damage. Replace any extension cords that are frayed, cracked, or otherwise damaged. When using power strips, use strips that have a built-in surge protector. Surge protectors can protect electronic equipment from damage caused by power surges. Do not overload power strips. Overloading power strips can cause them to overheat and create a fire hazard. Plug only one appliance into each outlet on a power strip. Inspect power strips regularly for damage. Replace any power strips that are frayed, cracked, or otherwise damaged. When working with electrical equipment, always use tools that are insulated. Insulated tools can protect against electrical shock. Inspect insulated tools regularly for damage. Replace any insulated tools that are cracked, chipped, or otherwise damaged. When working with electrical equipment, wear appropriate personal protective equipment, or PPE. PPE can protect against electrical shock, burns, and other injuries. Wear safety glasses, gloves, and other appropriate PPE when working with electrical equipment. When working with electrical equipment, keep the work area clean and dry. A clean and dry work area can help prevent electrical shock and other injuries. Avoid working with electrical equipment in wet or damp conditions. When working with electrical equipment, be aware of your surroundings. Avoid working near flammable materials or other hazards. Keep children and pets away from the work area. When working with electrical equipment, concentrate on the task at hand. Avoid distractions and take breaks when needed. Electrical work requires focus and attention to detail. When working with electrical equipment, follow all safety procedures and guidelines. Safety is always the top priority. If you are unsure about any aspect of the work, consult a qualified electrician.